Sitting at my desk here, showing what you need to know. Okay, because we don't really have time, and this is a shortened schedule. This is actually what 3-1's all about. I'm gonna extend the calendar that we currently have. Then this will be the transition calendar where I'll take this week and put it on our new calendar when I get that all figured out. Um, so you don't have to find a new hyperlink. You know what I'm saying? Anyone? Anyone know what I'm talking about? Okay. You deleted it already. That was a little premature, or whoever said that. But you always go back into Haiku and grab it because it still exists there. All right, so some of these things you should not really need me for, but I will cover them real fast. I'm going to go super fast through the notes. Your head will be spinning, and then you could always go back to this video and take the parts that you're not ready for, even though I think some of them you should. Like this. This is just, these are all things we're going to do today if you want to write this down. Plugging in numbers into an exponential function and then evaluating. When I solve an exponential equation by getting equal bases and then comparing the exponents, I think that is something you've done before, but at least what I show you when we do it, it should make sense. And for the love of whatever you believe in, you better know how to already graph an exponential function by plugging in points. So this is simple up here as well. Just representing or recognizing, I'm sorry. That's like playing the game. Remember function, not a function? Remember that game you could play at lunch? Remember that the polynomial game you can write at lunch? What is the end behavior? There's some other games that we played. Well, exponential, not an exponential. That's going to be simple. So really what it comes down to is this will really be the stuff that you might want to concentrate. And I'll slow down on the notes when we get to it. So you're just going to have to recognize what an exponential function looks like. By the way, that could be the beginning of your notes. That is the general form of what a general exponential function will look like, and we'll break that down when we get to the notes, okay? But evaluating, that's just order of operations. PEMDAS. What's the E in PEMDAS? Huh? Everyone? Exponents. But then there's also some rules that you need to remember that I'm going to go over real quick. That they consider bell work. But because we don't have time, I'm just going to tell you what you need to know. So this is 3-1. Here's my ugly notes that I've used over the years. Oh, sorry, premature. Here we go. This is what I wanted. And zoomed in nicely. All right. What's the cube root of a negative? Is it an I number or is it a negative? What's the answer to that? No time, it's a negative. All right, now I got a whole bunch of different answers. Did you hear them all? Someone said positive, someone said I, someone said negative. What's a negative times a negative times a negative, everybody? Negative. So it's not an I number. Square root of a negative is. How do you cube root a fraction? You cube root the numerator, cube root the denominator. I can't talk right now. I'm so excited. Now let's zoom in on this one. Look at this thing. What's a fractional exponent? There's going to be a lot of this going on that you need to remember these rules. And the problem is students don't. We've already covered these. And then it's the old rules that screw up the new things. So what does the 3 represent? It's a cube root. What's the cube root of 27? What's 3 squared? 9. That's how we got that. We've already tested you on that. You've already been tested on that in the previous question. So some of these things got to get figured out. What's the square root of 4? What's 2 to the 5th? Do the fingers. 2 times 2 is 4. 2 times 4 is 8. 2 times 8 is 16. 2 times 16 is 32. I don't know what all this red stuff is. I think it's a different question. Oh, that's just showing what we actually did there. We should not have to write that out as we go. All right? So if this is all too... Wait, slow down. No. This is anyone? Anyone? Review. Okay, then what do we do with these exponents? Well, I kind of show this off to the side, but what do you do with these exponents? Multiply them. All right, but then when you get 2 to the negative 12th, what can you do with 2 to the negative 12th? Flip, 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 flip. Flip, 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 flip it. That's how you get 1 over 2 to the positive 12. So knowing the negative exponent rule on these, massively important. Okay, because when we're dealing with exponents, these rules may come about. So this is no different. 1 over 3 to the 8th. What's a negative times a negative? So that's just be the 15th. And then maybe something on your calculator that you could do. You could find the 5th root button. It's called the X root button. And then what you'd have to type is 5 first, because this certainly is not a no calculator question. A lot of negatives in that sentence. This is a calculator question. instead of not being a no calculator question. But the ability to type it, there's two ways. And the other way is using the fractional exponent rule. This is the same as raising this negative to the 1/5 power, and you'd get that answer as well. Okay, take a pause for a second. Now you really don't have to write all this down, but just look at this and see what represents an exponential function and what doesn't. And the only thing that you need for an exponential function is a numerical based raised to a variable power. That is an exponential scenario. This is not. That is not considered an exponential function because the exponent is known. That's just a polynomial. In this case, a monomial. All right, so exponential, not an exponential. We'll play that game after this. Okay, now remember what I said about what we're going to learn today. I'll go back to this. When data is given and it's said to mirror or be an exponential scenario, this is the general format for an exponential scenario. This is something you're going to have memorized. All right, and then we're going to manipulate it a little bit in section 3 too, but it's not really a big deal. Just analyzing the b value a little bit more. So, an exponential function, let a and b be real number constants. An exponential function in x is a function that can be written in this format. And that's what you're going to have to remember when we give you a chart of values and say, from this chart, give me the exponential function that mirrors this chart. Now, do understand why a is the initial value. Pretend this is something that mirrors time for x. What is the initial value when you're starting an experiment? Where do you start? At time what? 0. Only one person said that. What happens when you take b raised to the 0 power? What's Mr. Samuelus raised to the 0 power? You wish. What does Mr. Samuelus turn into when he's raised to the 0 power? The number 1. Isn't that wild? Any variable raised to the 0 power is what? Any number raised to the 0 power is what? 1. Okay, so what happens when you plug in 0 for x? B to the 0 becomes 1. What's 1 times a? A. That's why a is considered the initial value. Very simple to figure that out. Okay, so first stupid little game that I might assign in the homework. Exponential, not an exponential. Number 2 is an exponential because the variable is in the exponent position. This is not an exponential function. That's why I crossed it off on accident. My pen's starting to write when it shouldn't. This is just y equals 16. What's y equals 16 a picture of? Starts with an L and ends with ein. Line. I don't have time for any of these questions. Okay, and then 6 is not. That's exactly what I told you is not an exponential scenario. The variable must be in the exponent. So stupid little game. Exponential, not an exponential. You can play with your friends. Okay, but now here's more with the bell work. You know, they are going to ask you questions about evaluating. I love, because, you know, like even your test that you took, the back page of yesterday's, actually you were not really supposed to have your calculator in hand. But I know we and some people over-calculated. They used the calculator too much. I wanted to see some more things done. But I'll have to leave it. This is definitely going to be a no calculator question. Definitely. Because the first thing I have to do is evaluate f of x equals blah for x equals -3, which everyone knows that this happens. Now, why am I making this no calculator? So you demonstrate what I talked about in the quote bell work. What does 2 to the -3 become? 1 over 8. 2 to the third is 8, but 2 to the -3 is 1 over 2 to the +3. Okay, so this becomes 1 over 8. I'm not covered. There is no y on this anymore. At a certain point, some of these things got to stick in your head, and you got to move on. Now, what's 1/8 of 4? Oh, here we go. 1/2. You better get 1/2 on that. Oh, he's so mean. Mean Mr. S. Mean, ogre, ugly Mr. S. Blah. Okay, ooh, look at the next one. No calculator? You expect me to do that? Yes! Now, what's a negative exponent do? When I plug in -3/2, what does that do? Now, does the 3/2 flip or does the 9 flip? It's the 9. I have people do that all the time. This becomes this, folks. My friends, if I may call you that. You know, and act friendly sometimes, Mr. S. I'm a tough friend. Tough love, I believe in. Now, also analyze this. Only 9 is raised to the negative power, so 3 does not move. 3 times 9 raised to the negative exponent. Now, without a calculator, well, I'm just going to do it this way. What's the square root of 9? 3. What's 3 to the third power? 27. Those are the numerate people. Oh, if you write that, I'll mark you wrong. How many times 3 go into 27? So the final answer is 1/9. And I'll pause for writing purposes. So again, this seemed to come out of left field, but this book likes to do, okay, we're starting with exponential functions. Let's make sure we know how to do things that we haven't done before. We have done before. Exact opposite of what I wanted to say there. Oh, a little rusty, and I'm rushed. What time is it behind me? Okay, now, so what time do we get out of here? 40, 10 minutes and counting. Okay, so this might be kind of like a continuation, but really all you need me is for the next thing. Now let's go back to this. And those did take that format, the a times b to the x, and we just evaluated. Now, using this formula to emulate data by hand. The reason I do this is so you can read a question. So back in the day, I helped the students read this one. In exercises 11 and 12, I assigned 11 for you. I'm doing 12 for you. Determine the formula for the, here we go, exponential function. Wait a minute, it's exponential, so instantaneously, I have no time for this. You yank this formula out. Since it's exponential, it must follow the a times b raised to the x format. All right, now let's look at 11 and 12 together. 12 says find g of x. What's g of x another name for? Y. So all they're saying, they created a multiple chart. You can actually do this on your graphing calculator. When you graph, I saw a student do that with me once. They graphed y1 and y2. Then when it went to the table, they had 3 columns. The first column was x. The second column was y1's y's. The third column was y2's y's. That's all this is. This is g of x output values when I input these x values. If anyone was listening to me earlier, we should know what the initial value is right away. We should know instantaneously what a is. What is a? I couldn't quite hear you. Not 1. What's the initial value for a? Not 0. 12. When I plug in what? When I plug in what? 0. So the initial value is 12. And I'll actually solve for that. Okay? So what I did is I used the yellow coordinate to denote why they call 0, 12, why they call 12 the initial value, why that ends up being a. Because when I plug in 12 for g of x, which is y, and I plug in 0 for x, just like I said when I showed the original formula, b to the 0 is 1, 1 times a is a equals 12. Now, quite honestly, I could use any coordinate now on this list. And actually, in the next example, we'll emulate that. On this list, I can use any coordinate to solve for b. Because now all I have to do is plug, anyone plug in, anyone, numbers for x and who? G of x or y. I like someone that said g of x there. And then solve for b. Why did I choose 1, 4? Because it's the easiest. Then we can check, does this emulate some of the more difficult ones? So I plugged in 1 for x, and I should get 4 for y after I get my initial value. So step 1, analyze what the initial value is. Step 2, take any other coordinate and plug it in on the chart and solve. And you end up with b. B to the 1/3, b equals 1/3. So it's 12 times 1/3 raised to a. Should I take 12 times 1/3 and get 4, and then it's 4 to the x? No. And it wouldn't even match that chart anymore anyway, because that's not how exponents work. only the 1/3 raised to the power. Then at this point, it would behoove you, what's that word mean? To maybe plug in one of these other values. Big yawn over there. So when I plug in -2, what's 1/3 raised to the -2nd? Ooh. What's 1/3? Come on, someone knows it. What's 1/3 raised to the -2nd? 9. What do you think 9 times 12 ends up being? 108. So I just checked another corner just to make sure it mirrors maybe one more of the chart values. And you'd be fine. Big blink there, you all right? Ooh, man, a stare down. He just looked at me and said, I'm not answering your question. How is this one no different? Well, it's a little bit different because how many coordinates do you see? 2. Isn't that all anyone? Need. What's the initial value, everybody? 2. Or if you really want to say it, but we know this is 2 because when I plug in 0 for x, b to the 0 is 1, 1 times a is a equals 2. So let's figure that out. What? What is this? What's this? What's this I see before my eyes? No time. What is this? What's 2 over e? What's e? What's e? 2.7. Good. 7, but not 4. 7. 1. Yes, yes. This is fun. 8. Who said 8? Who said 8 first? Was that you? I could have swore I heard an 8 over there. So exciting. All right. Anyway, that's a value we're going to maybe derive when we actually use it with logarithms and exponents and all this other stuff. So don't freak out. We can treat it like a variable. So when I plug in 1 for x, this is wild. I get 2 over e for y. Just deal with it. Plug it in. What's b to the first? Just b. What do I have to do to get rid of this 2? Don't say divide, though. What's better when you have a fraction over here? Multiply. Oh my gosh, here we go. What happens with the 2's? Oh, So y equals 2 times 1 over e raised to the x power. Or this could be 2 times e. What would happen with the exponent, just for fun? Negative x, right? Just the flipping rule. Let's see what they have here. Hi-yo! So if they were writing this as a multiple choice question, that's what they'd have listed, right? Then you'd have to know. Yeah, it's actually yes. Sure means. Okay, so you would have to know that that's potentially what could happen with this. 1 over e is the same thing as e to the negative first. Okay. Okay, and this is why you shouldn't need me. And actually, I should be able to go down to the graphing, but, you know, for graphing that, whoa, there's 5 minutes. What's all this, There's 3 minutes. Oh, yeah, okay, then put your stuff away, because we always quit class 3 minutes early, don't we? Don't you dare get that back out. Okay, now, remember plugging in points? I mean, this is why this should not be hard to remember this. And we did this. What's 3 to the first? What's 3 to the first? 3. What's 3 to the 0? I kept hitting my pen. 1. What's 3 to the negative first? 1/3. That should be enough to understand this behavior of this graph. What's that dotted line out at the bottom called? Asymptote. So we might have to do the graphing and solving tomorrow and kind of like finish this because the other notes are not too bad. But just watch this. When I plug in 0 for x, what's 1/3 to the 0 again? 1. What's 1/3 to the first, though? Well, it's 1/3. But what's 1/3 to the negative first? 3. We have people even standing up, blocking the notes. It doesn't even matter. It's like Mad Max in here. All the rules have just gone out the window, and it's anarchy. Okay? So all I'm going to say is this. And then I think we'll get those how to graph with transformations, which you should know already. But when you have a growth function, and notice we're just talking about, it's not the a times b raised to the x. We're just dealing with the b when y equals b to the x, all right? Ignoring the a for a second. When b is bigger than 1, you will get an increasing scenario. If the base is 3, 4, 5 to a power. But if b is between 0 and 1, then that's a decay. But then, of course, we know we could throw negatives in front of the function, right? What happens if I throw a negative in front of this? What does it do to that graph? If it flips it, what does that make it? Is it a growth or a decay? Okay, well, be careful on that. It flips it and goes here, so what is it actually doing? It's still growing, but it's on the other side. What if I flipped it over the y-axis, though? That's what I'd really be a good one. Then it would change it to a decay. So be careful. Obviously, we're going to do changes to these graphs. All right? And the changes we're going to do are these simple transformations that you see here. And I'll stop there. And in both classes, I'm continuing from here because second hour is supposed to watch this video. We'll see if they do, though.